So today we're going to look at motion with constant acceleration. What does it mean if an object is constantly accelerating? If the acceleration is constant, that means the velocity is increasing with a constant slope. And at the same time, that means the position is increasing with a parabolic slope. So this concept can be illustrated graphically. So if we draw the acceleration versus time graph, we can see that the acceleration is just a straight horizontal line. The slope is equal to 0 because it's at a constant acceleration, so it doesn't change. And if that converts over to a velocity versus time graph, that would be just a diagonal line, and the slope is constant because the velocity is constantly increasing. And if we look at the position versus time graph, constant acceleration is converted to a parabolic shaped slope for the position versus time. Now we can look at this concept analytically, starting with the velocity. So to find the velocity equation for constant acceleration, we can start by looking at the average acceleration equation and derive it from there. So if we start with ax equal to v2x minus v1x over t2 minus t1, where v2x and v1x is the velocities and t2 minus t1 is the time, and then we let t1 equal 0 and v1x equal vox as the initial velocity. Then we plug those values in, and then we can carry the t2 over to the other side, and then we get this expression here. And then if we isolate for v2x, we get this expression. And then we can rewrite it in a more friendly way with v2x on the left side, and then we can make it more general by changing the v2x just to vx, and changing t2 just to t, where vx and t can just be any values. So we get this equation here where vx is the velocity, vox is the initial velocity, ax is the constant acceleration of the object, and t is just time. So this will be the general equation to find the velocity at any time with constant acceleration. So I just want to make an important note regarding the axt term. The axt term is the product of ax being the constant rate of change of the velocity and t being the time interval. So therefore axt is equal to the total change in the x velocity from t equals 0 to t. And if this conclusion isn't clear, you'll see later in the video how this is true. So another note about this equation regarding the velocity. So the velocity at any time t is going to be equal to the initial velocity plus the change in velocity. So if we look at the equation vx equals vox plus axt, the first term is the initial velocity and the second term is the change in velocity. Another important concept with constant acceleration is relating it to the area under the curve. So if we look at the equation and we isolate for axt, we get vx minus vox equal to axt. The left side is going to be equal to the change in velocity at t1 equals 0 to t. And the right side represents the constant acceleration times time. So if we look at the acceleration graphically, we can see that it's just a horizontal line, constant acceleration, the slope is 0. And if we draw some random time interval and we highlight the area under the curve, we can see that the horizontal side is the time and the vertical line there is the acceleration. So ax times t is equal to area under the curve. And since axt is equal to vx minus vox, then that is also equal to area under the curve. And one last important note, even if acceleration is not constant, vx minus vox is going to be equal to the area under the curve.